that you are going to watch some videos and do the exercise after the video, and you are required to upload your grade result sheet as well as the certificate that you are going to get. So after completing each exercise, you are issued with a certificate, and for the Moodle platform, you are going to upload that um, the grade certificate and the result sheet, right? So you're going to get a report and you're going to get a certificate. You have to upload both. Right? So it's not anything for you to go and calculate and wait on the last minute to do, because you have to watch the videos and answer the question. So you should start it as soon as you can. In your spare time, you can just watch one of the videos and answer the question. All right? Now, as for the due date, it's going to be due next week, Tuesday, right? It will help with your unit test, and that is why I need you to go and do it before your unit test are. Right, your unit test is going to be next week because we'll be completing um, unit 4 today, which is illumination and lighting, and then next week. Let me just check again. I don't want to give you the test before time, right? I want to give you enough time. If I can push it back to the following week, I'll see. Let me check the outline. Anybody in here have checked their Moodle result and I've seen it? Anybody in the room?
Yes.
Okay.
Yes, sir. Check it out.
So are you able to see our result?
Yes, sir.
Yes, sir.
Okay then. Can you feel satisfied with what you are seeing? Yeah. I don't remember if I was able to. Yeah, man, I was able to record it. It's uploaded to the website to Moodle. Yeah, man. The link is there, and if you select the link, it will take you to um, the drive, and if you have access from before, you won't need access. If not, then I would have to give you access. Yeah, man, the drive folder. If you have the link for the drive folder from before, you can just access that link, and it will take you directly to the recording. If not, you have to go and Moodle. You will see under the unit, you will see the recording. There's a web link. You will send me a request to get that you are seeking access to. No, man, I don't remember the name. Let me check. Well, I can't check because I'm actually not logged in now. But what you'll see is just recording, lecture recording, and it will have one, let's say, 1A, 1B, or something like that. All right. Well, that is all we have to do. Oh. All right. As for your test next week now, so your test is going to be similar format. All right. Short answer and multiple choice. Right? Similar format to the previous unit test. Yeah. Problems. In my presentation I shared from before the class start,
Yes, sir.
All right, so today we should be looking at, are we going to look at illumination and lighting as it relates to facilities, right? Illumination and lighting is so broad, we could not deal with it under electrical systems, right? And we still cannot deal with it in detail under this unit, right? Because of the nature of illumination and lighting, some countries actually have a degree in illumination and lighting, right? It's a wide area, and we all can touch the major aspects as it relates to lighting and illumination. All right, let me start the recording now because I'm about to start the presentation. It's taking a while to come up, that's why I don't start it. All right, illumination and lighting, right? Personally, before we can look at lighting and illumination, we have to look at what a light source is and basically the terms that we are going to be using throughout this unit, right? If you are not familiar with the terms, you are not able to do the necessary calculations and relate to what I'm asking for, right? And right here we said the range of modern lighting fittings, basically and lamps, is so large that only the basic types will be considered. Right? That is just to iterate what I said before, right? So right now we're going to just look at the terms that are associated with illumination and lighting. The first term we're going to look at is the luminous intensity. It's denoted by L, and it's a unit. The unit is candela or CD. Now, what is luminous intensity? This is basically the measure of the amount of power that is emitted from a light source, right? And is sometimes referred to as a brightness. So when we refer to how bright a light is, for instance, you might say this light is not bright enough, a 5-watt bulb is not bright enough. We are really talking about the luminous intensity, right? So the luminous intensity is how bright, the intense of the brightness coming from the light. That's what basically luminous intensity is, and its unit is candela, right? Coming from the word candle. In previous time or in historic times, candle was actually the means of having light, and so hence with the development of electricity, lights were measured based on how bright it is compared to that of a candle, right? A single candle. And hence, we are saying that the brightness of a lamp is measured in candela, right? Luminous flux, right? Denoted by F, right? And the unit lumens. So the symbol is F, and the unit, you should be aware of this, is lumens. And basically, this is basically the amount of light emitted from the source. So the first luminous intensity was the brightness. This is really the amount the amount of light being emitted from the source, right? So we can use a light meter to measure this quantity, right? From any light source, whether it be the sun, whether it be a fluorescent lamp, a LED tube, and so on, right? So the luminous flux, or sometimes referred to as the flux, is really the amount of light emitted from a source. Illuminance, right? Symbol E is also measured in lumens per meter squared, or the lux, right? When we talk about how many lux coming from a source, it basically means the amount of light that is reaching a particular surface. So if we are in our room reading at our reading table, the light that is reaching our book that we are reading for us to be able to see the words is a measure of the illuminance, right? And right away you can see where the meters square come in, because we're talking about the area, right? And we are taking it as meters squared, and, right? So therefore, we can either refer to it as a lux that some persons are familiar with, or to get a better understanding of what we are talking about, we can say lumens per meter square, right? Which is really the amount of light source reaching a particular area, right? Surface area that is. All right, the efficacy, some person might call it the efficiency, is the symbol is K, and it's really lumens per watt, right? This is basically the ratio of luminous flux that we looked at before to the electrical power available, right? So it's similar, you can look at it as similar as to the efficiency of the light source, right? So efficient the light source is compared to another source. However, it is actually efficacy, right? So if we ask for the efficacy of a lamp, it's really the lumen per watt, right? Now, the maintenance factor. The maintenance factor is really is really a figure that you want to maintain in order to allow, right, for the buildup of dirt and aging of the lamp and all of this. When all of this occur, what will happen is that the lights start to get dull. Sometimes you park at a plaza and you see one man come and say, boy, we can clean up your headlight for you and make you see better at night, you know. Really what is happening is that our maintenance factor is getting smaller and smaller, right? Because of aging and exposure to the atmospheric conditions, right? So you give him a little 2 bills or a little 3 bills or even bills and him clean it up, what he's doing is maintenance service on your headlight, right? And this maintenance service will seek to restore the quality of the headlight to its original state, right? Very difficult to achieve, but that is why I say seek to improve, right? So the maintenance factor is really this factor or a particular factor ratio that you want to maintain your headlamps at or your lights at, right, from its original value, right? Here I give you an example to show you what I'm talking about. We say consider a new 80 watt fluorescent lamp. Remember, it's new, right? So the lumen output is going to be at its maximum, right? So the output is at maximum, so hence it is 5,700 lumen. After about 3 or 4 months, this output would have fallen and settled at around 5,200 lumen. But the maintenance factor have decreased, right? Initially, when we just buy the lamp, it is 100%, but now our lumen is at 5,200 after 3 months. Hence, the light output has decreased by a factor of the new output, right, which is 5,200, divided by the original lumen, which is 5,700. So we say that this value is 90%, right? This value of 9 or 0.9, 90% is the maintenance factor and should not fall below 80%. So we're saying in any situation at all, for good quality lighting, we should not let our maintenance factor fall below 80%. How do we maintain it then? Same like when you got a plaza and man clean a light. It means that for lamps or trappers in buildings or facilities, it means that we need to remove the buildup of dirt, right, and clean the diffusers, right? So we need to clean the diffusers. A lot of persons don't maintain this. What will happen after a period of time, we realize that the lighting level in the room based on the design lighting is now decreased, right? The importance of maintaining the lighting, the maintenance factor is that when you were doing your original design, the number of lamps would be based on the square footage inside the room, right? That's one factor to consider. Another factor is your paint, the reflectiveness of your surface and all of that, right? However, after a period of time, remember you didn't put any extra light. After a period of time, our maintenance factor now fall to 70%. That is saying that in a particular situation that the light is needed, especially in indoor situation with poor daylighting, meaning that the windows are not facing the movement of the sun or the sunnymost end of the building, right? Which is also a factor that you should consider when you're designing buildings. Is placement of the windows. So we are saying that at 70%, the quality of the lighting in the room now becomes poor. It will not readily affect the users in the room. But what if this was a room that you work in every day? Right? You go to work, you work in a large office space with a number of persons, and then after a while, you realize that your eyes start hurt, right? You're unable to see your work, and you wonder if you need glasses now and all of this, right? No, this may just be that the lights aren't maintained properly, the shades, and hence the maintenance factor is below the required standard of 80%, right? It's very important to know, like in terms of maintenance engineering, right? So for instance, you start a little company and you get a building to maintain to as a contract, you need to ensure that your diffusers become a part of the maintenance process. Similar to your AC, you want to clean your AC filters because they want the AC to work as efficient as designed, right? As can be. So same thing with the light. You want your maintenance factor to be the best it can be, right? And sometimes even for the lamp itself, sometimes what you have to do is actually replace the lamp. The lamp might not be blown, but after years of using the lamp, right, the efficiency and the maintenance factor is very low, and then it's better to replace the lamp, have a good quality in your home or your office space or your facility, rather than maintaining it at a low maintenance factor and affecting person's eyesight, right? So it's very critical to understand what the maintenance factor is. Now, the coefficient of utilization, this is basically the amount of useful light that when reach a particular surface. Now, this is going to be based on certain factors, such as the reflector, if there's the reflectiveness of the room, right? The type of diffuser that you use, right? And whether it be a colored diffuser, right? Whether it be a clear or a frosted diffuser. And for persons who don't know what diffuser is really the shade over the lamps, right? Is the shade we're talking about here. Now, the position of the lamp also going to determine the amount, the coefficient of utilization, meaning if the lamp is not directly over your surface, so where you sit in your office, you might not be directly under a lamp. So the amount of light reaching you at an angle is going to be less than that of a person that sits directly under the lamp, right? It's obvious, but there are calculations that they can do to determine the amount of light reaching the surface, right? We have to talk about the color of the walls, which I said before. Even the color of the ceiling is going to affect the utilization factor, right? Or the coefficient of utilization. So if the ceiling has a reflective paint, such as a white paint and so forth, that will reflect most and not absorb all the light, well, it will also affect the lighting, right? For instance, you paint your house, it was in a particular color, you paint your room, right? And you realize when you put a fresh coat of paint, even if the paint is the same color, you realize that the room becomes brighter, because what is happening is that you have restored the reflective quality of the wall, right? If you change the paint and probably lose a lighter paint, then you realize that the room now becomes brighter as well, because you have increased the reflectiveness of the room, right? So all of these will determine your utilization factor. Now, when designing, you as a designer of the light, right, will have to determine the utilization factor based on the space that you're doing your calculations for. Typically, what persons do is tend to do, or persons that don't know the calculation tend to do, is use a rule of thumb rule in terms of position the lights, right? It will not always work out for the best, because some persons will just put the light in the center, and putting the light in the center does not mean that all areas of the room have adequate lighting, right? So you might have areas that have a dull or poor lighting, and then it will affect persons after a period of time. Now, so being that we finish all of these terms, we need to look at the different type of lamps. This is one of the most famous lamps, right? Or bulbs. Persons would have known about this, right? Younger persons probably don't know about it. They might tell us that, oh, sir, the red lamp. Oh, yeah, mom, I know what it is. But for persons in a particular age group will know what these filament lamps are, right? Basically, remember when you check if it blow, you screw the bulb and you shake it, right? That to hear if the filament fall off, right? They're basically listening to see if the filament fall off on the stem to tell you that the lamp is blown. Right, now there are two types of filament lamps, right? They are in terms of the base or the connection, right? You have the Edison screw type, right, which was developed by Edison, right? And you have the ED or push in and twist, right, type, which is shown here in the diagram. And on the end of the, and to the left of the picture, this is the Edison screw type. Now, in terms of knowing the different parts of the lamp, you should be able to identify them, right? You have the bulb, which everybody is aware of, the part that will break when it falls. You have the filament part. This is the part that the current will pass through. It will glow, and you will have the light rendering. Stem that is going to hold that the filament is mounted on, right? You have your bulb being cemented on the conducting cap, right? The side of the cap is really your neutral, and in some cases, in terms of the Edison screw type, but in this type of lamp, the side of the cap is just to hold in the lamp, right? If this is a particular single contact lamp, in some cases, then one will be your live pin, and one will be your neutral pin. In some cases where, like a car bulb, if you're using a push-in car bulb, then for a single contact, the side will be your negative, and the contact at the bottom will be your positive, right? So when you actually fit it inside the indicator or your headlamp or your brake lamp, then it will work in the manner. For insulation purposes, then the two terminals or two contacts are insulated with ceramic type material, again, from touching each other, right? So we don't want any short circuit. Now inside the lamp, there's a connection, right? A filament connection connected straight to the filament to the contacts, right? For the one that the negative is at the side, then one will be connected to the metal caps, will be connected to the center. So for instance, in the Edison screw type, you have one end of the filament coming directly to the contact at the bottom of the lamp, the screw type, right? And then one coming to the tin where the screw threading is, right? To denote your neutral leg, and your positive leg or live leg would be connected to your contact. Now, to actually increase, right, the efficacy of these type of lamps, normally they will tend to use a double filament, right? So using a double filament will actually increase the efficacy. Now, also, a lot of these, sometimes these bulbs are full with gas, right? Basically to increase or reduce the light loss due to the heat loss, right? So what they do is use an inert gas inside here to actually cool the lamp itself, right? So that you don't have a lot of waste or loss due to heat, right? But again, you might want the heat, right? You might be able to utilize the heat for different purposes. Like as I say, I normally tell persons, what about the person who raised chicken, right? Because when I was small and my grandmother raising chicken, she usually buy these lamps to keep the chicken warm throughout the night. So it serve a dual purpose, keep the chicken warm and to let them have light to see if anything will come in the pen and attack them, right? Or the chicken coop and attack them. So it serves two purposes. So she's not really wasting any energy because she's utilizing the loss as heat, right? So these type of bulbs are hot to the touch them, right? And before touching, you have to make it cool down for a period of time. All right, we have our different types. We have our vacuum type, right? The vacuum type filament lamp. The filament operates in a vacuum in a glass tube, right? It has a poor efficacy, right? And meaning that the efficiency of the lamp is very poor, right? And that is why they encourage you to change from these type of filament lamp to your LED lamps or your compact fluorescent lamps, right? So the efficacy is around, or the operating temperature is around 2000 degrees C. So this is how hot it will get, right? So you can realize that a lot of, right, or the energy consumed will go to loss, right? You have the gas field type. It will operate up to temperatures of 2500 degrees C. Inert gas will cool, create some cooling effect so the lamp won't burst or the lamp won't, the bulb itself won't overheat and blow, right? And we say the efficacy is increased by the lamp by making the lamp opaque, right? So that is why when you buy these filament lamp, you really don't see it clear, right? You will see it have a coating, a white coating that will sometimes obstruct your view in terms of seeing the filament, and that is why in times gone they usually shake them if they are blown, right? So they actually coat it for a particular reason. Talk about the efficacy already, so we don't need to stress this some more. This is just iterating what we are talking about. Now the color of the light, tends to be mostly red. That's why persons are the red looking light, and yellow and its basic form, right? This type of lamp is used only in situations that do not require high level of illuminance. But before, we can say this now, before when it's the only available lamp, right, we could not say this, right? However, in current times or in modern time, then we can say that these lamps are really, we can buy a low wattage lamp, right, for chicken coops, right? So it will keep the chickens warm and provide them some amount of lighting for them to throughout the night. However, it's becoming more and more difficult to get these types of filament lamp, right? So as time go on, it's very difficult to get these. Discharge lighting, right? Basically, this type of light relies on gas and inert gas being ionized in a glass tube, right? So it will be in a glass container, glass tube, right? And then you will ionize the gas to produce the necessary light required. In this type of lamp, because of the nature of it, discharge light, high voltages are present due to the ballast, right? So due to the ballast used for these type of discharging lighting purposes, then a high voltage is present, right? An IEE regulation states some precautions that we must follow when we introduce light discharge lighting in our facilities, right? Typical discharge lightings, you see them every day, neon signs, your regular fluorescent lighting, your mercury and sodium vapor lamps. These are your outside lamps and so forth, right? Your floodlight type lamps, right? These are basically examples, such as the street lamps as well. These are basically examples of discharge lamp. Now, the first one we're going to look at is your neon tube, right? Basically, I just give you a little annotation here to say that persons call it neon, but that's not really the name. It's just as though Hoover is used to indicate the vacuum, or what we call a megohm or megameter, right? It's actually an insulation resistance tester, but because Megabrand was one of the first type of insulation resistance tester, then people tend to say, let me a mega, right? We need to use a mega to test the insulation resistance, right? But it's actually an insulation resistance meter, right? And in today's environment, we have a lot of different manufacturers. So we don't, but once you say mega, everybody knows. Similar to Tangent when we were doing our plumbing, we know that Tangent is a brand, right? The correct name is actually PVC adhesive or PVC cement, right? But persons tend to say Tangent and everybody know what they're talking about. So when we say neon lamp, everybody know that what we are talking about, but it is actually a discharge type of light, right? There are, in fact, several different gases used to give different colors, right? Including helium. So in the same neon tube, they can use helium, not only, right? They can use nitrogen and they can use carbon dioxide. All of these will serve the same purposes, right? And depending on the different type of color that they want, whether they want a warm light, whether they want a daylight, and so forth, right? It will actually detect the type of gas that is used will determine the type of color rendering you get from the lamp, all right? Now, so I'll show you an example. This is an example of a single neon sign circuit. So we use it to energize the volts, right? So in the part of the circuit that you are not seeing, the part that is displayed to you, you will not see these connections. But behind the sign now, there are connections similar to what is shown here, right? We realize that all the lamps are basically connected in series, all the tubes, right? So we have a series connection that is connected to their discharge lighting circuit, right? So we have our distribution board here, or our panel box. We have our fireman switch, or circuit breaker, right? We have our power factor correction capacitor because of the induction involved, right? We have to use a power factor correction capacitor for this type of light. And then on the transformer, we'll actually step up the voltage, the supply voltage to high voltage to actually ignite the gas inside the tubes. All right, now this is basically self-explanatory. As fourth-year engineers, you should be able to describe the function of the circuit, right? Here I'll give you some some reading, right, in terms of the sodium vapor type. Now, we are saying that it is of two types. We have the high pressure and we have the low pressure sodium vapor lamps, right? The low pressure type consists of a U-tube, right? It's double thickness glass, right? The inner wall of which is covered or coated with silica, which can actually withstand. It's coated for a particular purpose because we are talking about sodium becoming hot, that is going to become corrosive to the bulb. So to prevent it from heating away at the glass, it is coated with a neutralizing agent, which is basically silica, right? Inside the tube is a quantity of solid sodium, right? It's solid, and a small amount of neon gas, right? The neon gas really helps to start up the discharge process so that the sodium can ignite, right? The outer glass envelope stops too much heat loss from the inner tube, because remember we're talking about to actually ignite the sodium, we have to run it up to some serious temperatures, right? So we look at that further. Now, this is an example of the low pressure sodium type, right? You might find them in display signs, like in supermarket and so forth. What they'll do is actually put it behind in a casing, where the casing, the front of the casing might be printed to show a particular display. So what they do is actually put the low pressure sodium type bulbs behind, and when it's ignite, it will actually shine through the printed part of the sign to indicate whatever they want to advertise, right? So it's utilized a lot in advertising signs and so forth, right? And it's normally mounted in the horizontal position, right? It can be of an angle of plus or minus 20 degrees, right? Because of the sodium becoming hot, this is why we want to mount it in the horizontal position so the sodium can be distributed evenly along the tube, right? If it's mounted in a vertical position, then what will happen is that it will be concentrated at the tips, right? At the tip here, right, or down here, and it will discharge. Actually, after a while, it will start to eat away at the protective layer, right? It will start to eat away at it. Now, the high pressure mercury vapor lamp, right? This type of lamp consists of a quartz tube, very to actually prevent, right? It's a very sturdy quartz, right? Very sturdy type of containment. And this is really to maintain the high pressure that will develop inside the lamp when the gas is ignited, right? In this type of lamp, we use actually argon gas to start the ignition process, right? So there are three electrodes, two of which are the main electrode and one auxiliary, right? The auxiliary is usually used for starting, so it is the one that will ignite the argon gas, and then the other two main electrodes will take over, right? This is actually shown in figure here, right? So figure 5 here is actually a high pressure sodium lamp. So you will see these in your street lights. You can find these in your outside lamps as well. Like if you want to light up a netball court and so forth for outdoor purposes and so on, right? So you have here, you have your two main electrodes, so them here, right? And you have your auxiliary electrode, right? You have your hard glass tube, right? Here you have your high resistance, right? This is what will reduce the current here for the starting purposes, right? So we don't want too much current to flow, so it will start the argon gas, and then the main electrodes will take over. All right, and we have our Edison screw type here, which is basically of the ES type, right? So this is actually utilized again for now persons tend to call it the Goliath Edison screw type, because when you actually look at the discharge lamps for high pressure mercury vapor lamps, the tube is larger than the regular I should say incandescent tube, right? It's a very large tube, and hence to hold the weight of the bulb, what is on the inside parts, what will happen is that they have to increase the size of the Edison cap, right? So it will not fit in your regular outlets or broad-based receptacle outlets. Rather, it will fit in your dust till dawn light. So like your dust till dawn will have a Goliath type Edison screw, right? So here we're just showing you the starting purpose. This is all that we have just said for the diagram, right? This is just showing you the starting circuit and the type of resistance. So we'll talk about high resistance. We're talking about approximately 50 kilo ohm, right? We have our choke, right? To choke actually to reduce the starting current that is drawn by the main electrodes, because everybody should at this point understand how a choke works. On the sudden closing of the circuit, right, the choke will tend to oppose that inrush current, and then after a while it will reach its maximum current, right? And we have our power factor correction capacitor because of the choke, right? So the choke is an inductive element which will start to which would add reactance to the circuit, hence resulting in a low power factor. So to offset that, or to improve the power factor, a power factor correction capacitor is used, right? All right, our low pressure mercury vapor lamp, we're talking about our fluorescent tube, right? In today's society, we are even moving from our fluorescent tubes to LED tubes, right? The conversion process is simple. It's just a matter of removing the starting circuit. If you want to utilize the same spine, right, the part that the fittings, right, is known as the spine. So if you want to utilize the same spine, what they normally do is just remove the starting circuit, which is the ballast, whether it be an electronic ballast or an electromagnetic ballast, right? All you need to do is remove it. If it's a T8 type, you follow the connections that is shown on the tube, right, and so on, right? So you have different types of connection for the tubes. Now, so before you actually put a LED tube into a circuit, you need to identify the type LED tube you have. Sometimes you have to make modifications, connection, right, before you can actually change the tube. Right, so when you are buying a replacement tube for LED, it's always best to take out the tube that is there, look on the T type, whether it's a T8 or whatever number it be, and try to replace it with the same one. However, if that's not possible, you can always modify the connection to fit the type LED bulb that you get, right? Um, all right, so our typical fluorescent lamp consists of a tube, glass tube, of which the interior of the glass tube is normally coated with phosphor, right? So the inside of the fluorescent tube is normally coated with phosphor, and that is really to aid again in the cooling process and the starting process. Now, the tube is filled with mercury at low pressure, right? Again, this type of tube is should be disposed of before I move on in the proper way because of the mercury present, right? We don't want to dispose of it incorrectly, and then we have what is known as leaching in the environment, right? It's really harmful chemicals seeping into the environment, right? That's really what leaching is basically is. Now, so we want to dispose of the mercury tube in the proper way. Normally, it's best to place them in the box that they come in, right, and dispose of them in a seal bag, right. So you put them in the seal bag and then a hazardous container bag, right. It's different from a regular garbage bag. It's much thicker and it's designed for that purpose, right. At each end of the tube now, right, is situated an oxide coated filament. So each end of the tube, you have the filament that will ignite the gas inside the tube, the argon, and will basically start the lamp, right? The discharge takes place when a high voltage is applied across the ends of the tube. So you see that ballast that we talked about before, this is what will produce the high voltage, right? Inside there is a transformer and it will produce the high voltage, and the high voltage will go to the tube to start the tube, right? Now, when the supply is switched on, so the practical application, the circuit is completed via the choke, right? And the lamp element, the starter switch, right? We're going to look at what I mean by the starter switch, right? And then the neutral. So it will continue through the starter, the choke, the filament, one end of the filament, then it will go through the starter switch, then it will go through the other side of the element, right? And then to the neutral to complete the circuit. Now, the elements which are coated in oxide, when you apply the voltage, what will happen is that it starts to warm up, right? So that it starts to warm and then it starts to emit electrons, right? Now, these electrons now actually start to ionize the gas inside the tube, the argon, the inert gas, right? A person might say, sir, but gas in the tube right now explode. Inert meaning it's non-flammable, right? So it will start to ignite the argon inside the tube, right? And that is the process through which the ionization takes place. Now, after a period of time, the starter contacts, right, due to the current passing through them, right, the choke will open up, right? So the starter is connected to the choke and then it will cause the choke circuit to open and it will actually maintain the high voltage inside the lamp, right? So you can actually read through the rest of this. This is just explain. I want to go to the circuit to show you what I'm talking about, right? Here we have the switch closed. Our initial sense is that for this circuit, the choke again, in terms of the inrush current, will reduce the inrush current while applying a large voltage. So it will ramp up the voltage, right, because of the transformer involved, right, in the starter, in the ballast, right, and then what will happen is that the high voltage now is going to be present across the tube. Now, with a high voltage present across the tube, this is where it starts to eat up the elements here, right, and then cause the circuit now to start to ignite the argon gas inside the tube, right? Again, because of the choke and the transformers involved, right? We have to put a power factor correction capacitor, right? This is really to, again, to improve the power factor because of the inductance, right? Here we have the starter for persons who are aware, right? If it's an electromagnetic fluorescent lamp, the starter is really that little metal casing, right? Cylindrical in nature that is normally sticking out either one side of the spine, right? So it will, or for some lamps, it's placed inside the spine, right? For some, you can access it outside the spine. Some you have to actually pull the cover, take out the bulb, pull the cover, and access the starter to change it, right? Because without the starter, right, what will happen is that this will not, you realize if the starter is bad, then we cannot close the circuit, right, to actually provide the starting current for the tube, right? So we definitely have to have a good starter to be able to produce. Now, the output of the fluorescent tube, right, is we consider the fluorescent tube to have a really high efficacy or very efficient, right? Actually, converting from fluorescent to LED in some cases don't make any sense unless fluorescent go bad, right? Because the efficacy or the efficiency is so close, right, that it doesn't really affect your bill much if we're talking about a one lamp, right, compared to that of when you have a facility now, when you have where you have many lamps, then converting all of them to LED will definitely affect the bill, right? So we have to have a lot of them before and convert them to actually see any difference. But if we're talking about a one lamp or a two lamp, you will not see the difference much because of the high efficacy of fluorescent tubes, right? So we're saying for a typical 125 watt tube, the lumens, we will get about 70 lumens per watt, right? Now, table one here shows basically the color rendering of different fluorescent tube, right? We have the white and warm light. Some person might be generally, I'll tell you some general application, generally phone, right? Join offices because we want the white light to be as bright as possible, right? When we talk about daylight and not on natural light, right? So when we talk about daylight, we are talking about natural type light. This can be utilized in any situation, basically. But most it will find application in jewelry and glassware, etc. Right? So this type of light now will make your jewelry look nice. So when you go to the jewelry store now, right? And you see the watch or you see a ring under the daylight or the natural light, it tend to look shine and nice, right? But when you take it out now and in a certain location, you say, but it don't look shine like before, right? This is really because of the light that they use. Now, artificial daylight, you'll use this in areas where you really want to see the true color, right, of the surface or area, right? You have the deluxe warm light. We use these in offices and buildings, right? Where, like, for instance, restaurants and furniture store. So they want them furniture to look shine when you go into the store. So boy, the craftsman work look nice, right? So they use these type of lights. Right, I have north light. We can use them for tailors and furriers, right? We have deluxe natural light. They use them for florist shop, flower shop, right, butchers and so forth. So make them meat look rich and redder. You got the shop and say, boy, that beef look nice. You're looking at the showcase at the supermarket, you realize that the beef look nice under the light. However, when you take it from under the light and go home, you realize that, but it never looks so. You start wonder if the beef start touch, right? It's just a trick that they use with the light. So knowing the different color rendering of light, you can use them for different effects, right? And then in the supermarket, you got the ground provision, you say, boy, no man, them orange look nice, the apple them look nice under the light in the supermarket, but when you buy it on carton, the apple look different, right? So these are ways that they use lighting, right? Even when you're talking about entertainment and on-stage performance, the lighting, you see they take pride in setting up their lighting and all of this because they know that if the lighting is not adequate and proper, then they'll not get the effect that they want, right? So there is really, that's why they tell you that when you're watching the show and them tell us, no man, that's a camera trick, right? And they use light in the blue screen effect to basically get what they want, right? No, when we talk, yes.
Uh, Before I switch slides, I wanted to get a recommendation. If studio area to do some recording for live stream, what kind of lighting would you think would you recommend for me to
Is
use?
it that you want it to look more natural?
Yes.
So you would go with like either daylighting or the warm white. So these will give you a nice effect for or glow of the skin then. Right? So when
Yeah.
you talk to the person, you have to put on a whole heap of makeup, right? Because it will give you it's kind of like when you do glamour shot, and you say, but wait, a shot doesn't look like the glamour shot is actually set up with them come with them lighting and you see them come with them umbrella thing and them focus the light and them thing there. So them use a warm light type of warm white
Oh,
for actually make your skin look glowing. Like when them look on somebody and say, boy, that person have glow man, them skin look nice.
yeah.
Right?
Yeah.
So it will give you that effect.
Okay. All right.
Right? Come on. Now, what the warm light will do, it will take care about the furniture and the person itself.
Okay.
Right? Yeah, so it will show up the furniture, make the furniture look nice in other place. Whereas if it's a natural finish, right, it will enhance the effect of the natural finish.
But I
Right?
would have on the lumens in order to prevent shadows.
Yeah, man, but that will come to your calculation. We'll come to that next and the position of the lamps,
Okay.
right? So how you position the lamps in other place, and the type is going to determine, meaning how high it is in the ceiling. Because in a studio now, what them do in the when you go to a photo studio, because at the height of the building being 9 feet above the floor, right? Some in some cases 9.5, or some cases even 10. What they do is that they need to focus the light more, and that is why they use the umbrellas with the light, because the light is too far away from where they're going to take the picture. They're not gonna get the effect what they want. Right? So to actually get the effect what they want, they will tell the persons that you will see them come on them adjust the lighting or they make it set up at a place, particular location. So once you come in and sit on the chair, them know so that are the perfect lighting, because they might take the pictures so long, right? But if they were to go to a different location, so they might go to a location where they might go take some shots, right? Either here the photographer come now and in position here and him say, no man, turn away here or face the way here, right? Because of the
Right.
effect that they are actually getting when they're looking through their lens, the shadows and so forth, then
Yeah.
they position it to reduce the shadow effect.
And if you have the shadows, it affect the background if you're using the green screen. So
Yes, it
another
does.
part.
Yes, it does. Right, any type of screen, once you have the shadow, even if you put up, even like when you go UTech and you're going to take your photos, right, for your ID, you realize them have the screens behind you. And you notice that when you go, you realize that the colors of the screen, them kind of look burn out. But when you take your picture, you say, wait, the background look, you know? It look
Yeah.
like it new, right? That is really the effect what them get from the lighting inside the room,
All
right?
right.
When you're ready to take the IDs. So lighting in itself, and I'm not going to tell you that I know everything because I am not a lighting specialist, but it's something where you can research and you can get information on, and you can do your calculations and get on trial and error. Because even when we know as engineers that when we have the perfect design, even when we go to buy the components, because components and stuff are not ideal, then we have to tweak with design to get the desired effect. Same way, when you do your calculation you're not going to get the ideal effect what you want, and then you have to position your furniture, you have to probably position another backup light to get rid of certain shadow and so forth, right? So that like for instance now when they say you are at home and you're talking on your device, try to stay behind the light, right? Meaning the light be in front of you, because when you are actually, the light is actually behind you, the person is not able to see you properly, right? So these
Yeah.
are techniques that them use in terms of lighting, right? So there are many stuff, many stuff, right? All right, points to note when we're using discharge lighting, right, is that if you have a discharge lighting, the switch must be designed to break an inductive load, meaning that if your load is, for instance, in this case, 5 amp, then your switch should be able to break 10 amp, right? Twice that of your maximum loading capability, right? Because of the initial um, inrush current, which we know will be present based on the type of discharge lighting we're using. So before it gets to steady state, we're going to have a sudden inrush, and then the choke will take effect, and then it will start to reach your constant steady state, right? So it will tend to demand a high current, but because of the choke, it going. So all of this happening in a seconds, you know, when we're doing networks, I analyze the instant the switch close and the instant the switch open, and when it reaches steady state and so forth, right? Or transient effects. All right. Calculating lighting requirements. This we're going to look at some simple calculation that we can do to actually calculate the lighting requirements. That is basically the amount of light reaching a particular surface, right? And this is why we actually design surfaces to be actually a maximum of 3 feet, because this is basically our design optimal design height. When we talk about our ceiling, right? Whether the roof is high, when they put in ceiling, they try to maintain it at either for residential 9 feet or 9.5. For buildings, they might go to 10 feet, right, and so forth. In areas where you have high reaching ceilings, you realize that they tend to want to have wall mounted lights, right, to have the desired lighting level at their reading surface, right, or the utilization surface. Now, um, one thing you need to realize that if we were to actually measure, right, the amount of light reaching a particular surface, if we were to move away, or the light tend to move away from that surface, realize that the amount of illumination, if you were to measure it, is going to be actually 4 times less, right? So it's not really how far you move by, you know, that it will be a little bit less. It's actually 4 times less, meaning if I am directly under the light and I move away, right, I am saying that that movement, or the move, if the light was to rise, meaning say in a building they tend to ice the roof, right? And when they ice the roof, they take the lights are now positioned higher. What will happen is that if the lights are not redesigned, right, you're going to have less um, light reaching the surface, right? And that is because of what is known as the inverse square law effect. Now, what is the inverse square law? The inverse square law is just really saying that if you were to move the position of or away, or move the light source away, or you move away by 2 times the distance, your surface or your circumference of your circle or the plane that you're utilizing is going to be actually 4 times whatever the distance, original distance is, right? How do we do that in terms of calculation? This is basically it, right? Where we have the illuminance E, right, is equal to luminous intensity candela over the distance squared, right? So in essence, it's E equal to L over D squared, right, for the distance. Then what is able to see that, right? So I repeat again to let you know. All right. So example, so I have an example to show you what we're talking about. We are saying that a light source, 900 candelas, right, is situated 3 meters above a working surface, right? They want us to calculate the illuminance directly below the source, right? And then B asks what would be the illuminance if the lamp were moved to a position 4 meters from the surface, right? So here, in A, realize that the distance is 3 meters above the working surface. So our illuminance right here is where will work out to 100 lux, right? Our illuminance in B, being that it is now 4 meters, right, above the surface, then we realize that this becomes 56.25 lux. So it has decreased, right? So realize by how much? By just adding 1 meter to our distance, right? We realize that our lux has reduced to almost 50% of what it was, right? So basically 3 feet, we move the thing 3 feet. So this is like for your countertop, and then you are getting this at your countertop, and then when we measure at the floor level, because the countertop is normally 3 feet away from the floor level. So this at the floor level, in the same position, we'll realize that we are getting almost half of what we had measured at the countertop, right? So it's very critical in terms of calculation. Now, give you another example, right? This we are moving at a angle, so we are saying 250 watt sodium vapor street lamp emits a light of 22 I mean somewhere in this question. It should be 22 let me check about the question, guys. Just give me a quick minute. I think it's 22 meters. I don't know because this is a meter above the road. Calculate that. Let me check it quickly. I should have the question. As I take it from my question box. Oh, it's 22,500 candelas, right? So it's actually, let me change it in my slide. It is actually reading it as that. All right, so it's actually 22,500 candelas, right, are shown there. and it's situated 5 meters above the road. Calculate the illuminance, right? That A, directly below the lamp, B, at a horizontal distance along the road of 6 meters, right? So they want us to calculate it here, and they want to calculate it at 6 meters. For persons who don't know what 6 meters is approximately 18 feet, right? So that's basically 20 feet away in some sense. All right, here in A, the illuminance directly is going to be I, right, divided the amount of candelas, right, illuminous intensity, here divided by the distance squared, right? So in this case, the distance squared is going to be 25, and the amount of lux reaching the surface of the road is going to be 900 lux, right? For B, because the lamp is at an angle, we can use trigonometrical ratio to determine the angle here. And if we have the angle here, it's just a matter of using the cosine rule to find the amount of lux at this point B, right? So here we actually find the angle. We find the angle to be 50.2 degrees, right? 6 over 5, the tan theta, A over AB over D, the distance, right? We get 150.2 degrees. Using the cosine rule, we develop the new equation for the lux, right, illuminance, where that I times cos cube theta, right, divided by d squared is going to be equal to the illuminance at an angle, right? So it's just a matter now of filling in what cos cube theta is. We find here I find actually cos theta, which is 0.64. Matter of filling it in the equation now, we have the illuminance, luminous intensity here times cos theta cube, right? And then we divide by d square. We know that d is the distance or vertical distance. So now we get 236 lux, right? Don't know what I'm reading, 236 lux. So realize that the amount of light reaching this particular area has reduced by a significant amount, right? By just moving away horizontally from under the light, right? And you can see this in nights where you go under the street light. At that point it is bright, but when we move away from the street light, then it starts to get darker, right? Now, how do we facilitate for this when we are doing our designing our buildings, right? So this next question will actually take into effect all the different aspects, right? A work area at bench level is to be illuminated to a value of 300 lux, right? So we already state the lux because of the type of area is a workbench, so we want as much lux as possible. From standards, established standard, we realize that when we're talking about workbench and work areas, 300 lux is actually sufficient, right? Using 85 watt single fluorescent fittings, right? Having an efficacy of 80 lumens per watt, right? The work area is 10 by 8 meter, right? The maintenance factor is 0.8 or 80%, and the coefficient of utilization is 0.6. They want us to calculate the number of fittings required, right? The number of lights. Now, to do that, we realize that the total lumens required is going to be the amount of illuminance that we need at the surface times the area that we want to illuminate, right? Divided by the maintenance factor and the utilization factor, right? So what we get is actually 50,000 lumens, right? So we are saying to light the area properly, right? All over the area, we need 50 lumens, 50,000 lumens, right? So this is the lux that we need, right? At any point in the facility. So at any point, we should be getting 300 lux, right? So to have that level of illuminance, we need 50,000 lumens. Now, since the efficacy of the lamp is 80 lumen per watt, right? So the total power required is 625 watt. It's a matter of dividing the amount of lumens, total lumens required by the lumen per watt of one lamp, right? So this is basically the efficiency of one lamp. So we are saying that for the entire facility, we need 625 watt. Now, if each lamp has a watt of 85, so for each lamp, it will produce our required 85 watt. It's now a matter of dividing this 85 into 625 and we get 8. So we are saying that if we were to have 8 lamps positioned equally throughout this space, right? And why equally? Because we are talking about the area of the space, right? So if we were to have the lamps positioned equally throughout this space, then we will be able to supply the 300 lux, right? So we'll be able to supply the 300 lux at all points in a facility that is basically 30 feet by 24 feet, right? So that's basically what we are saying. So I'm saying for 30 feet, which is really a big space, we'll need 8 lamps at 85 watt, right? So if we realize that if we had chosen a different particular lamp, right? If we were given a different type of lamp, right, we'll realize that it will also change the amount of lamps that we need, right? So before we can do our lighting requirements, it's always best to use what is typically the lighting requirements for a particular area, right? Which is the lux, the amount of lux. And then based on the amount of lux, we can determine using particular lamps. So we must have an idea, right? Normally what our designers will do is use about 3 different type of lamps, right? So these are the designers, you know, they might tell the people them say, all right, because the people in this one was when they finish and go in at the place, they are able to see and what they are looking at is looking nice, right? So our designer will actually do 3 or 2 set of calculation using different lamps. So if one not available, then you are able to select another type, right? Now, if we are talking about fluorescent lamps, we need to be able, because in most facilities now, or most workshop, right, or shop floor, a lot of the bulbs are not changed out, right? So we're talking about fluorescent tubes. And if we are talking about fluorescent tubes, we have to discuss stroboscopic effect, right? What is this? Basically, this is the effect that causes moving objects on a fluorescent to seem as if they are standing still, right? So because of the effects of fluorescent lamps being the frequency dependent, the light will tend to oscillate at the supply frequency, right? So it will oscillate. The lamp is going to oscillate. It's to the naked eye, you will not see it, but under rotating machines or moving machines, then it will seem to be that the motor is running slower than actual. And you can see this in like workshop. If you were to go to like the mechanical workshop at UTech, you'll see this effect if you're under a fluorescent lamp, right? And there are ways for our purposes in machine shop, this is not a desired effect because we don't want the machine look like it got turn on when it actually turn on, right? Because this is a danger to a lot of persons working in the workshop. Or we don't want to look like the motor, the machine is actually going slower than it's actually running at, right? So this is basically an undesired effect in most situations, right? Now, to minimize stroboscopic effect, we have two methods that we can utilize, right? We have the um, balancing method and we have the lead lag method, right? What are these two methods, right? The balancing method is normally utilized when we're talking about three-phase circuits, right? Now, in a particular facility, for example, if we were to have a three-phase, so it's a big facility where you use lathes and rotating machine and motors, three-phase motors, then definitely we have a three-phase switchboard or a three-phase panel. Now, to minimize the effect of stroboscopic effect in this type of facility, what is done is really to group alternate. So for instance, I have a set of a branch, let me get a pen. I have a branch of lights, right? So here I have a set of light, here I have a set of light, and here I have a set of light. Now, in our panel, this might, I will want to put this on, say, if it's a, probably put this on line 1, right? Or might put this on line 2, and we might end up put this on line 1 again, because remember, if it's a three-phase facility, most likely one of the leg them going to be 190. We not utilize that 190 with neutral. If we're talking about 110 lights, we're going to use the legs that are not 190, right, along with our neutral. No, so we are saying that because of the shift in phase, right, what will happen is that by doing this to the balance, the lighting effect or term balancing, right, what will happen is that because of the phase difference, this light will strobe at a different oscillation than the other line, and they tend to be of equal oscillation because however they are oscillating in at a different phase, right? And because of this, what will happen is that they will tend to cancel out each other, right? Similar to when we're talking about our RCD, residual current device, or GFCI, right? What will happen with this is that they are of equal phase. So what will happen is that they will tend to cancel out each other, right? And reduce the effect of stroboscopic conditions on the machine itself, right? The another method is basically the lead lag method, right? No, the lead lag method is basically same grouping of the lamps, right? So for this particular method, we get a capacitor, and the value of the capacitor is such that the lamp, right, unit, it is fitted to as an overall leading power factor, right? So what will happen is that any pair of lamps have a lagging and a leading power factor, basically, right? So we are saying that in a facility, pairs of lamps will have lagging and leading. So it's a matter of grouping them again in their lagging and leading so as to cancel out the effect of stroboscopic condition, right? So they're actually what it means that it will tend to reduce, right, or to make redundant the scope, the flickering effect, right, in the two groups of lamp, right? So these are different ways where we can actually use two different ways which you can actually use to minimize stroboscopic effect in fluorescent lighting, right? And again, you will not find these in LED lighting. So based on what is happening today and we are going LED, you will not find these effects in LED lighting, only in fluorescent lighting. Now, person might say, but sir, I'm going to use fluorescent bulb at home. Yes, because the ones that we usually call energy saving are CLF, right? So for persons who don't know, it is actually CLF. So the C is for compact, right? No, it's actually CFL, not CLF, right? CFL, right? So it is for compact fluorescent lamp, right? So these are the energy saving lamps that we normally buy in the supermarket, right? Energy. Let me get back. So these are for the energy saving lamps we normally buy in the supermarket, and so we are actually saving energy. Yes, we are, but we're also introducing our stroboscopic effect, right? So our energy saving lamp. So if you were to have a compact fluorescent lamp at home, and you tend to look on your fan while it's spinning, right? Sometimes it seems as if yes, the fan is spinning fast, right? But what will happen is that you'll have a strobe effect taking place with the compact fluorescent lamp on your fan, right? So yes, you do utilize fluorescent lamp. However, they find a way to compact it inside your house. Now, this is why the base of these type of lamps are larger than the regular filament lamp, because the starting circuit, right, or the electronic starting circuit is inside the base of the lamp, right? So all we are seeing is the fluorescent tube, and at the base you'll see a larger part that actually contains your starting circuit, right? Your electronic starting circuit. All right, things that you need to note when we talk about get to know your bulbs, right? We talk about the incandescent light. They are most like sunlight, provide warm light, are really typical in interior, so we find them in interior situation, are the least energy efficient. A 60 watt will only last about 750 hours, right? So after a time it will blow, right? The industry is starting to phase a lot of incandescents out, right? Best for floor or table top lamps, right? Chandeliers and so forth, or even kitchen pot lights, right? So for instance, like your rice cooker and so forth, you have some of them have a LED bulb, some of them have an incandescent bulb inside of them, as well as your stove hood might have a incandescent lamp in it, right? It's best for this situation because it can handle the heat coming from the stove. Now, when we talk about your halogen lamp, right, it has more hours, operating hours, than a simple incandescent lamp, can get quite hot to the touch, right, have high energy consumption with a typical halogen lamp, provide warm light as well as that of the incandescent lamp, right? When we talk about the fluorescent lamp now, or the compact solar fluorescent lamp, right? They are energy efficient because we call them energy saver bulbs, right? But not as good quality in terms of color rendering. So it have the filament lamp will have better color rendering, right? Provide more of a cool light, can be dim but not very well, meaning it's very difficult to dim putting a dimming circuit in your fluorescent, compact fluorescent or your fluorescent bulbs are delayed in coming on, right? Fluorescent tend to be better suited for areas that are not as important for task or mood lighting, right? Think more in garages, basements, always that don't get as much traffic. But this is changing. This has changed because of the advances in compact fluorescent lamp. So this is really talking to a regular fluorescent tube, but with the advancement in compact fluorescent lamp, then this becomes um, not applicable to that, being that we can get compact fluorescent lamp in different types of tubes, right? We can get warm light, we can get daylight, and so forth, different color rendering, right? This is where the technology is at now. Light emitting diode or LED lights, right? Expensive but last the longest, right? And are the best on energy savings, meaning it's even better than that of the fluorescent, right? Typically make colors look great, right? So it have better color rendering capability. The industry is continuing to develop the technology, right? Lots of incredible options coming out, right? So meaning that as technology improves, such as um, the lights that are available in LED, like the ones that when the light goes, it have an internal circuitry to store energy, so it have a little energy storage battery in there, and you're able to produce light for probably an hour after your light go, right? So that is basically because of the LED does not require a lot of current, right, to start them, right, and to provide light, right? So it's much better than that of the fluorescent and the incandescent type lighting, right? And even our automotive industry have changed a lot of the cars. So a lot of cars, not even high-end, because first time we'll just talk about high-end vehicles having LED lights, right? But now we're talking about all type of vehicles carrying LED lights, right? They are much brighter, better color rendering at night, right? And they look much better on the dashboard and so forth. All right, so this would have taken us to the end of our lesson for today. So we are not staying long today. So you can use the rest of the time to start read up on for your tests next week at this time, right? So next week your test is going to be open at um, 12 o'clock, right? And it will close at or the same Friday or same Thursday like before. So it will open during the same period to incorporate persons who have their class on Wednesday and Thursday, so as not to shortchange anybody, right? Before next week, all the grades should be out. Some person, as I said before, should be seeing their grades now on both platforms, right? I will continue to mark. It's very difficult to mark from the computer, guys. I have to sit and read in front of the screen all day and read all of that thing. But I still have to give you short answers. So for persons who were late, your test is going to include multiple choice and short answers like before, right? It's going to cover unit 3, so that is our mechanical systems, and it is going to look at unit 4, which is our lighting. Now, the assignment for persons who are late, by later today, your assignment will be available on Moodle. No, your assignment is actually going to take you to a website. It is known as your building whole building design, right? It's an American site. So it's a whole building design guide. You're going to be completing 3 short webinars, right? One on advanced lighting systems, right? You're going to look at advanced lighting systems. You are going to be looking at advanced interior lighting systems, and you are going to be looking at daylighting principles and strategies, right, for sustainability. So we are going to be looking at three headings, right? We're going to be looking at advanced lighting, and exterior lighting, 4. So we're going to be looking at advanced lighting, right? We're going to be looking at interior lighting, exterior lighting, and daylighting principles, right? So it's going to be a 3 short webinar to wrap up unit 4, right? The test again is going to be open from next week, Tuesday. So we'll not be having any class next week, Tuesday, right? I'll give you the time. If you don't want to do it in that time, as I tell you, it's open from the Tuesday to the Thursday, right? However, once you start the test, it's restricted, right? Meaning it's time, and when your time expires, it is going to automatically submit your paper wherever you are, right? So you have time to complete next week your daylighting principle by the time you're ready to take your test, right? That is basically your advanced lighting system, your interior, your exterior, and your daylighting principles, right? So, and again, you are going to be required to upload your result sheet for each one, for the different webinars, as well as your certification, right? So this will determine your individual mark for the module, and then you will be given a group assignment, which is to be given at sometime after next week, right? You'll be given a group assignment that you are going to do in your groups, and that you are going to actually so I don't want for the group assignment to reach there is not individual submission. I'm going to make it a group submission, but for your individual assignment you have to submit your individual. No, please don't try to be very cheeky like persons last year, right? In that they uploaded their certificate, but yet still I can't say the name on the certificate. I have tested this site, I've gone through it before, so I know that when the certificate is printed, your name is shown on it. When the result paper is printed, your name is shown on it, the day that you do it, the time that you take the test, and all of that, right? So you need to do the test for yourself. Try not to get somebody's certificate and try do whatever you want to do with it to submit, right? It will show that it is not authentic. So you need to go on the webinars and go through the exercise yourself, as well as it will help when you come to your test next week to complete your test too. All right?
Sir, can you repeat that, please? My internet was breaking up.
No, I'm saying for test 2, what you're going to do for your individual assignment is going to be part of your test 2. You can see questions from it pop up, right, when you're doing your test 2. So don't shortcut and feel that you can go around the thing and don't go through the exercise. Right.
Mr. Mark,
Yes?
in terms of the assignment, how soon that must be done, or what is the time span we get to complete that?
It is going to be due next week. As for the day, I don't want to set the day, probably next week, Friday. So even though it's after the test day, you know, make sure so you try to do it. That is just for submission. But because you're going to need to go, it's some short videos. You just need to watch them. After the video, you have some questions. Before you can watch the videos, you have to register to the website. It's free, right? Even though we go through them webinars, them on different series. It's not just lighting them do all sort of thing, right? it's a free American website where they go through different engineering principles. I registered a couple of years ago, right, when I find out about it, and they normally send me link for different webinars, right? And when I go through the webinar, it asks some questions. They do the questions, it generates a certificate when you pass, right? And it gives you the result sheet, right? So it do that. So yes.
those topics that you said that we should watch are the webinars supposed to cover?
Yeah, man, it's part of Unit 4.
Okay.
Yes, it's a writing.
You're going to post it as a reminder.
The Moodle is going to have the link to the different tests, the whole building design, and the different tests that the different webinars that you need to go through. All right.
Okay.
I'm going to put it on. Yes.
As it relates to the webinar, sir. So as after we have registered, sir, and they give us something to watch, we'll have to answer questions directly that they will actually grade and give us a grade, sir.
Yeah, it's going to give a multiple choice after you watch the webinar.
Oh.
Yeah, and so directly after you watch it, it's going to give you some questions to know if you have pay attention or you leave it around and go about your business. So it is forcing you to watch the videos.
So how long is each of those videos, sir?
I don't remember. But you have time. Remember not something what you can do in the evening after you do everything. It's like an assignment, you know. It is not, you know, it don't mean say you have to do it 2 o'clock today. It don't mean say you have to do it 5 o'clock today. You can do it tonight. You can do it earlier morning when you wake up and in the quiet of your home, right? And so forth. So it's not like an assignment. It's just that you're watching a video rather than you going and researching something. You just watch the video, answer the question, and trust me, last year persons, you hardly get anybody hardly feel it. Most of the grades were over 70. Nobody get less than 70. Right? So it's not anything hard they're going to ask you because they can't expect to ask somebody, watch a video and then ask some hard question after. Right? So it's just some simple question to show that you were, to test if you were actually paying attention to the video and the knowledge that you have gained from the video. Actually, enough people did get 100 last year. So then basically they get all of the mark for them individual assignment, right? So it's a way to help persons that are falling on test 1, right? Yes, you do have persons that are falling on test 1, right? And to help these persons, right, the assignment is designed to help them, right? We don't want persons to spend their money and then come couple weeks from now them start to cry and so them feel, right? We try to help you as much, but in helping you, we want you to learn, all right? So just watch the video, man. Nice video, nice little certificate you're going to get. If you want to print it and put it in your house or put it in your portfolio, you can put it, right? It's actually recognized within the United States as an online webinar. It's actually a federal organization, right? So it's a it's a .org site. It's federal. It's something that is recognized in the United States. All right. All right. So I'm going to leave you now. Stop the recording, and by tomorrow morning, by late tonight, you should see the links on the Moodle platform, right? And you should be able to start your reading and so forth.